Ping.
All right, it's red. Yep.
All right. All right. All right. Welcome back to Angular Nation. I'm very excited about today. We have our old friend Peter Bacon Darwin, who did a really cool conference talk at NGBE a couple weeks ago, JavaScript generators. And I actually have not looked at JavaScript generators. I haven't been paying any attention, and apparently they're very cool. So I asked Pete to come and give us his talk, and also because now you have a little bit more time to go into some more detail. And we were talking, so you were saying you have a lot to cover, so you're going to like speed run through some of it because you want to get to the part that you actually want to show us, and you have to set the foundation.
Exactly. Yeah. So generators is a topic which has been around for 5 years, right? But most people in the JavaScript world just are only vaguely aware of it or not aware of it at all. And even those people who are aware of it probably haven't actually used it in production. Like, it's quite unusual. When I was at the conference, I asked like a hands up, who knows what generators are, and they're like 5 hands out of about 100 or something. And then
we got Sander with his hand up over
Sander's
here.
in there. Yeah, I'm not going to be teaching Sander anything today. He'll know it all already. Then I said, right, so who's used it in a production environment? And it was like one person, then Sanders again. Yay, cool.
Sander's our resident overachiever.
So this is one of these cool bits of technology which could potentially, open your eyes to something new. It totally blew my mind when I first got involved in it. So.
And it's already there, available to us. It's like built in.
ES6. It came out in ES 2015, right? It's been around for 5 years, 6 years.
Wow.
So all of the providers, all the browsers, Node, Dino, everyone has it natively now. So you can just get stuck in. Right. So I'll start
presenting. Us. This is exciting.
Not often do you get to hear about something new in the JavaScript world that's not just a fancy library. Cool. So this talk was slated NGB for, not slated, it was, well, slated is the right word, but that sounds bad. The plan was it was going to be 20 minutes long. I realized when I was writing the slides that at very least it's about 46 minutes long. So I cut a bunch of slides, and then they gave me an extra 5 minutes. And in the end, I took like 35. And that was me really rushing through. So I'm going to rush through again so that we can get through as much of it as possible. And I'm hoping anyone who's actually in the meeting will stop me if there's any issues that you want me to clear up. Otherwise, I'll just assume that you're following along. There's a lot of code on these slides. And you can see if you're at home, this bit.ly link here is the link to the slides. And I think you might benefit from going to this link. It's on the top of every slide. And that will allow you to follow along with your own copy of this. And you can then sort of look at each of the slides if you find one that's a bit confusing, you can spend some time. So starting with confusing, here we go. This is a page which contains 3 things called sagas. And a saga is, I can't post the link in the Slack because I can't copy this link because it's part of the like this, the background. But maybe someone who's on the call could copy it down. It's 3 capital D, capital Q, lower J, lower L, lower G, and then a 5. So if someone else can paste that, then there we go. Glenn's sorted it. Right. So these are actually sagas, which is a thing that was created as a kind of plugin for Redux. And I came across this stuff in 2015. I was after we just finished the first AngularConnect. I was all excited about creating an app that the attendees could use to have a better interaction at the conference. So they could like look at the schedule, they could interact with each other, we could do Q&As and all of this kind of stuff. So I started building. Oh, it's a 1. Fair enough. Or is it an L? No? Anyway. So I started building this thing. And this was an AngularJS time, right? Angular 2 had barely even, I think it wasn't even out at that point. So I was building this thing. There was no such thing as NGRX. Redux was pretty new and cool, so I was using Redux. But I found that handling async workflows within Redux was a bit confusing because it's not really designed for like managing asynchronous workflows in the way. It's more of this sort of stateless sort of store. And I tried various ideas like thunks and other things, but then I came across Sagas, and it just totally worked in my mind. Like, this is how we should manage these things. So what I've put up here is some Sagas, and they're actually generator functions. Now, you don't need to understand this right now. I just wanted to put these up here so you can get a feel for what a generator function looked like and how it just looks like normal real code. Like, we've got these with a few like things in, like this word yield and these stars and stuff. Anyway, we're going to come back to that. That's where we started up. This is what got me going with generators. And I've spent the last 5 or 6 years just secretly loving these things, and trying to find ways to sneak it into my code. And it's really like, it's not that easy. But there are some scenarios where I think it's really powerful. So we'll come across some of those as well. Anyway, what I'm going to do is like rush through an introduction to generators. And the way that we have to do it is, first we have to understand iterables, which are things that we can iterate over. Then iterators, which is the thing that an iterable provides, which you iterate with. Then a generator, which is a special kind of an iterator. And then finally, generator functions, which is what we saw on the last page, which is these cool functions with yields in, which actually create generators. So an iterable is just something you iterate over. You can stick it in a for of loop, and it will just get iterated over. The class, there's loads of built-in ones in JavaScript, like set and map, and objects are iterable, and so is an array. And that's the obvious classic example. But what does it actually mean to be iterable? Well, what it actually means is, behind the scenes, an iterable thing has to have this function on it, this method called iterator. Now, in the spec, it's called @iterator. But @iterator is not actually a valid JavaScript identifier. So in reality, in real world, we have to use this symbol.iterator to access this method name. But I'm just going to use @iterator wherever I need it, because it's just easier to write in this. But if you're actually writing these things, you would actually do symbol.iterator. So you can see an iterator is just, an iteratable is just like an object that exposes this iterator method. But what is an iterator? So an iterator is actually a thing which exposes a method of its own called next. And what you do is, when you've got an iterator, you just keep calling next on it, and it just returns you this object which tells you what the next thing in the iteration is. So you can see here, I've got this array. It's an array of 1, 2, 3, and I get the iterator from it, and then I call it.next. And you can see it returns value 1, value 2, value 3, and then from then on, it's just undefined. And it has this nice feature, which is that there's this flag called done, which just tells you when you've finished. And once you finish an iteration, that's it. You can keep calling next forever, but you'll never get anything new out of it. It'll just keep saying, I'm done, I'm done, I'm done. So if you imagine what we looked at earlier, this idea of for of, when that actually happens inside the JavaScript runtime, what's really happening is that the JavaScript runtime calls this @iterator method, and then it keeps calling next until result is done. And then at that point, it breaks out, right? And then if it's not done, then it runs whatever's in the body using the result.value. And this is actually how it really works, right? So all of the built-ins have this method on them. And if you want to create your own custom one, all you've got to do is provide this @iterator method. So how would that work? So first of all, we need to actually create an iterator. So this is a fancy little iterator called the Fibonacci Iterator, which I've just devised. The Fibonacci sequence is this cool kind of triangular number sequence where each of the values is created by adding the 2 previous values. Hello, new joiners. Hopefully you can keep up. And this is a class which has this next method on it, but it doesn't have to be a class. It can just be any object which has this next method on it. And you can see what we can do is we can create a new instance of this, and then we can call next, 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 and we get the values out until we get a done at the end. So now we've got an iterator, we need to actually expose an iterable for it to be able to be used in a for of loop. So I've got a function here called fib iterable, and it returns an object which contains the iterator accessed by this iterator function. Now we can actually pass that straight to a for of loop. So you can see here we're creating the iterable here. We're then iterating over it using the for loop, and you can see that it returns 1, 1, 2, 3. And it stops when the result is done. And you'll, interestingly, also with a for loop, it extracts out the value. So you don't actually get the object from the iterable, you get the value of each iteration. So that's what an iterator is, and that's what an iterable is. So now we need to understand what generators and generator functions are. So a generator function is just a really clever new thing in JavaScript, which you've never come across before, which creates a generator object. Now, you can see it's special because it's got this little star next to the name here. And that tells us that this isn't any old normal function. This is actually a generator function. And we'll look at exactly what a generator function does and how it works in a minute. But what we can see is that when we run this generator function method, it returns a generator. And a generator is actually just another kind of iterator. So we can call next on it and get values out of it, just like we were doing earlier. What's slightly crazy is that a generator is also iterable. So it's both an iterator and an iterable. And to just mess with your brain even more, the iterator that you get from calling at that iterator is the generator itself. So it's kind of like a self-referencing iterable iterator. This is why I said before we started that there's a lot of kind of confusing terminology here. You don't really need to understand this. Really, all you need to know is that by a generator being both an iterator and iterable means that it makes it easier to use in for-of loops. And we'll see how that works in a sec. So what does it actually mean to be a generator function? So I've got one of the simplest possible generator functions on the left here. It's called for, and funnily enough, it will, when you iterate over it, you'll get 4 values out of it. What's really interesting, though, is this is not just a normal function. Like if there's a normal function, you call it, it would just execute all of these statements one by one, and then it will exit. But when you call a generator function, nothing happens at all. What actually happens is that the generator function creates this generator object and sets it to be positioned just at the beginning of this first statement here. Then every time you call next, it will execute the statements in the function until it hits one of these yield expressions. When it hits the yield expression, it stops. And that is what will be returned from a call to next. So when we call this first next here, it will execute through until we hit this yield 1. And the 1 is what gets returned to this console log. And then it pauses. So basically, the generator function will pause at that point and stop executing. Then when we call next again, it will now start running again, and it will go through until it hits this next yield expression, and it will yield the 2, and so on until we either get to the end of the function or we hit a return statement, in which case we get, in this case, the value 4 is returned. And because it's a return statement, we get done equals true. And then just like any other iterator, if we carry on calling next, nothing happens. It just returns done, true, done, true, done, true. Let's see how it works with for-of loop. So because the generator that's produced by this generator function is also iterable, we can pass it straight into the for-of loop without having to worry about creating our own iterable. So we remove a whole load of that boilerplate that we had earlier. What you'll notice, though, here is that when we iterate over it using the for-of, we only get 1, 2, 3. That's because this return statement here had the done is true flag set. And if you remember how we looked at how for-of works with iterables, when it hits a done true, it breaks out and it doesn't execute the body anymore. So anything that's being returned from this generator won't actually be included in a for-of loop. So you just get 1, 2, 3. So that's pretty simple, straightforward. Doesn't provide you with much benefit at this stage. But we can do some really pretty cool things with generators, which are a bit more tricky to do with normal iteration. So first of all, your generator function doesn't have to ever exit. You can just have an infinite loop in a generator function. Now, when people see this for the first time, they're like, whoa, you've got a while true in there. That's a big red flag, right? Suddenly, your reviewing hat comes on and you're like, whoa, I found something really bad here. This is always going to be bad. But actually what happens here is, because this is a generator function, it never actually continually executes. So we don't get into an infinite recursion. Every time we hit the yield expression, we stop. So it's up to us how many times we go through this loop. So we can see here that we call it next 1, 2, 3, 4, 5 times. We get 5 values out. But if we don't call it next again, nothing will happen. This thing is just paused. It's not going to do anything else. What's really cool about that is you can actually imagine, like, these lazy infinite sequences can be computed on the fly. They can be pulled in from other places. It stops you from having to think up front how many iterations you're going to need. It's up to the user of the generator to actually decide how many steps you want. You can even use this kind of thing in a for-of loop. But of course, with for is going to keep calling next until we get a done true. So if you did do that, you really would get an infinite cycle. But instead, what we have to do is we have to break out of the loop when we've had enough, because evens is going to produce an infinite number of results here. But this is pretty cool. Even just this simple idea is we're putting the power of, like, how many iterations we want from something into the user of the code rather than the creator of the iterator. So the person who builds the generator doesn't have to worry about adding logic to worry about how many iterations are going to be generated. I think that this actually makes the code, like, even cleaner. So here's our Fibonacci sequence again, but this time generated using a generator function. I've also removed this max value because we now know that we can exit out by just breaking. So you can see here that the code just looks really clean and simple. You can see exactly what's going on, and it reads like it's just a normal function, except you just know that every time you hit a yield, it's going to produce a value here. And then we obviously have to break out of the loop when we've had enough. So one of the really nice things where I've actually seen this in production quite often is when you want to iterate over an input sequence and do some processing on it, which will involve more than one of the elements. So in this case, what we want to do is group each pair of elements into their own little array. And so each iteration, we're going to return a pair of elements. Now, this is a bit tricky to do. You could do it with like an array.reduce kind of function. But that array.reduce doesn't really work very well with infinite sequences. Also, you have to keep creating lots of intermediate results and keep track of what's going on from the previous results. Whereas here, you can see that we only have to create an array when we actually are generating an output. So from the point of view of performance, memory consumption, this kind of thing is really powerful. Another really cool scenario, and this was actually suggested to me by Alex Rickabow of the Angular team, who spends a lot of time working with trees on the compiler. If you've got a non-linear structure that you want to iterate over, a generator can do that really powerfully and in a really concise way. So what we want to do here is we want to iterate over this tree, but only return the leaves. So we only want to return the 2, the 5, and the 6. And what you can see here is we have a generator function called leaves. And what it says is, OK, if there is no children, so there's no left and no right child, then this must be a leaf. So we yield that value. If that's not true, then what we do is we use this new syntax called yield star, which basically says delegate all of the rest of the yielding to this other generator function. So then we call the same leaves function, but using that left branch. And then this will now iterate over that left branch and produce all the leaves in the left branch. And then we go to the right branch and we delegate to this leaves again over the right branch. So this is a super, super simple, clean function that allows us to iterate over a complicated structure, producing only the values that we care about. So this is the moment where my brain explodes. This is the point when I realized, yeah, recursion. So this is able to actually recurse into itself, which is like really hard to get your head around when you're thinking this isn't just normal function calls. This is actually a generator that is creating another generator, but then delegating to that generator. And it just happens that the generator that you're delegating to is a new instance of the same generator that we're in at the moment.
Pete.
Yeah.
I can do this exact same thing without using a generator.
You can do everything in this talk without using a generator.
No, but exactly the same code. If I leave out the yield, it will
Right. What if you only wanted to get the third item in the list, right? If you leave out all of the stars, what's going to happen is this will run and it will generate it'll just return. So if you change these yields to returns, right, then it's only going to, it'll stop when it hits the first leaf. Yeah. So if you changed all of these yields to returns, then this yield here is going to hit this first two and then it'll stop. That's it, you're over. You'll never get the 5 and the 6.
That's true.
So what you would have to do is not yield the node. You would have to add the node to some array, which you pass in at the top here, which then gets passed through the tree so that you're building up this array as you go along.
That's true.
So basically, you're just adding extra boilerplate to this. Also, it means that you've got no way of controlling when this stops, right? Because if you wanted it to stop after the 4th one, then you'd have to add some code to here that says, oh yeah, and when the array gets to size 4, then return out, right? Which means that the generator, the leaves function, then has to know about how many things it's going to iterate through. Whereas as a generator function, I could literally just call next, 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 next. Right, I'm done. I only wanted 4 items, and then you just stop, and the generator stays the same, however many things you want. So you can for sure get this kind of behavior or a similar kind of behavior. You can also use like visitors, patterns, and things like this. But you end up having to put more boilerplate into it to handle different scenarios. And one of the cool things about generators is it allows the control to be outside of the generator. That's the thing I think is really cool. And this is going to become even more interesting when we step into the next bit. So generator functions are just iterators, right? And it's a cool way of making an iterator because the code looks like a normal function, but it acts like an iterator. But generators are also state machines because there is a state inside that generator function which is maintained between calls to next. And the people who created the generator spec did one thing, well, a few things, but one particular thing which made it 10 times more powerful. And that is they allow you to pass values into the generator function as well as getting them out. So at the moment, every time we call next, we're just calling next with no values, and it just returns you the next value from the generator. But we can actually call next here with a value, right? So here what we're doing is we're calling next with a value, and this value char is being passed in to the yield expression here, and it is the result of the yield expression. So when you call next with a char here, what happens inside the generator is that the yield expression will actually have that value that you passed in. And this is just like, this particular slide is a kind of a toy example of like, I'm just going to count the number of vowels, but you know, the state is the number of vowels you've counted. We're going to just iterate forever. And then what happens is every time next is called, we get a new character. The character then gets tested to see if it's a vowel. And if it is, then we add up the add to the count value, and then we come back around here and we yield that value back out. So the yield value here, this count, is what is returned from this counter here. And then we can use the value here to log it out. So what you've now got is like 2 things which are kind of interplaying. Like one is talking and then it's passing control to the other one. That one does a bit of programming and then it passes the control back out to the original caller, who then does a bit, and then they can pass it back in. So it's a way of getting 2 processes to kind of run side by side. And in other programming languages, you talk about these things as like coroutines, which is like a way of doing asynchronous programming. So what you're doing is like interleaving the processing of 2 different functions. And this is the thing that makes generators super powerful and really exciting in my mind. And we'll see some examples of why this is cool. in order to help this as well, on the spec they also added two other things. One is that you can, as well as passing a value in, you can tell the generator that instead of receiving a value, I want you to just throw an error at this point. You can also tell it that you just want it to exit at this point. So you just want to return the out of the generator altogether and just stop generating new values. But what's really amazing about this is that when these things happen, the normal semantics of a function carry on as you would expect. So what we're doing here on the right-hand side, you can see that we are calling evens to get a generator function. Then we go next, next, and that gets us the 2 and the 4. And then we're actually going to throw a value into the generator. And you can see here that in the generator function, it has a try catch block. And the catch block is actually going to catch that throw that came in from the outside. We can then catch that throw, do something with it, and then recover and carry on. So you can see here, look, we've outputted the 2, the 4. Then we caught the 20 that was thrown in. And then we continue. We now start outputting 22, 24, because that's the way that we set it up to recover. And similarly, with a return, the finally block gets called when you try and exit. So whether it's a throw or whether it's a return, if we return or throw at this yield point here, the finally block will always get called before the generator finally leaves. So all of the things that you know about how functions work kind of work with generators as well. So you can use the same mental model that you have for normal functions, but using generators, except you just have to understand that whenever there's a yield point, then that is the point where the function will pause, and it will then give the value back out to whoever's controlling it from the outside. Hopefully that makes sense. Feel free to go back and look through these slides, and at the end we can go dig into this a bit more. But these three things, being able to pass a value in, throwing, and returning, completely revolutionize what generators can be. So what we've done so far is just manually called like next, 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 next on the generator function. But what becomes really powerful is that you can write functions that will drive any generator function. So you can pass in a generator function to some driving function, and it will then drive it by calling next and doing stuff with it. And then you can actually put in different generator functions, which actually act like different state machines to this driving function. And it will just drive through the generator and do whatever you wanted the generator to do. There's a few examples here, so I'm going to step through a few of them. This is hopefully where Zonder's going to start getting this excited, because we've kind of got through like what generators do now, and we're now into like more of the interesting use cases. So one of the things that you can use this for is actually to add instrumentation around the yield points. So imagine that you wanted to do some logging. So every time you yield a value, you want to be able to log that. You want to do some logging around that point, so before and after that that value gets yielded. So this is my driving function here is called run hook. It takes a generator function and some hook function. And what this is doing is it's going to iterate round and round the generator until, and every time you get a value out, it's going to call the hook function with whatever that value is. So here on the right, you can see I've got run hook. I'm passing in the yield for generator, and I'm passing in this simple log function. And what's going to happen is that when you run that, it will log out the value 1, then the value 2, then value 3, and value 4. What's really cool about this is that the generator itself doesn't know anything about logging. Yeah, all it's doing is its business logic. I'm just doing my business logic, and I'm yielding values. And it's the hook function that knows about logging. So this is a great way of separating out the responsibilities. And it's the driving function, this run hook, that then brings it all together and makes it work. So I could use any generator function instead of this yield for to actually to execute some code. And as long as I yield at every point that I want to have some logging happening, this run hook will just deal with it for me. There's a similar thing going on in MobX. So if anyone's used MobX, what you'll know is that any change to the state has to be done inside this thing called an action. Now, actions normally are just wrapped as part of like a function call. But if you've got an async await call, then after every await point, you've actually fallen out of the action. So the way that you have to do it is you have to put the next bit of code inside this call to run in action so that it ensures that the writing to the employees list is done in the correct action. You can imagine this boilerplate gets really ugly after a while. So the MobX people came up with this driver function called flow. This flow is actually part of the MobX API. And instead of passing in an async await function, you pass in a generator. Now, what happens here is that when you call get employees, that returns a promise. But instead of awaiting it, you actually yield that promise to the flow driver. The flow driver then goes, oh, this is a promise, so I'm going to await it. And when it's finished, then I'm going to make sure that everything that runs after this is going to be inside the right action. So it does all of that boilerplate for you. And you can see now that this generator function here is totally clean of boilerplate. It doesn't need to know about actions. It just has the business logic as you'd expect it. And again, this is one of the things I think is really cool, and this will lead us on to what happens with Sagas later on. You'll notice that in the MobX one, when they got a promise, the flow driver function was clever enough to say, okay, you've got a promise, so I'm going to await it. So you can actually do that kind of thing yourself. And what I've got here is a generator function. This is a generator which this is a driver function which takes a generator, and what it does is it's going to iterate through the generator, and every time the value that's passed to it is a thing which is an instance of a pause object, it will actually use timeout to pause a certain amount of time before it actually continues. Otherwise, it just runs it straight away. So we can see if we pass in this generator function to run and pause, the yield 5, yield 10 will both happen immediately. Then we hit this new pause object, which is being yielded, and the run and pause driver is going to then go, oh, okay, this is a pause object, so I'm going to pause for 2000 milliseconds. So it sets a timeout. And when that timeout finishes, then it will carry on iterating through the generator function. So then it will output 20 and 25. Then it's going to pause for another 2 seconds, and then it's going to output the 30. So if you were to watch this in an animation, you'd see like 5 and 10 immediately, then there'd be a pause for 2 seconds, then 20, 25, then a pause, then 30. So this is a way of starting to think about asynchronous programming as a kind of a dance between your business logic and the thing that's actually going to control the business logic. And if you think about it, async await is just syntactic sugar for this kind of thing. When you have async await functions, the async indicates that this is going to be controlled from the outside, and the await is effectively like a yield point where you're going to stop and wait for the promise to recover. As well as actually pausing, you could actually cancel a generator. Now, this is something that async await cannot do. Like once you've got a pause and it's running, you can't cancel that promise. It has to run to completion. Whereas with a generator, you can actually have a function. What we're going to do, this is very similar to the previous function, but as well as having this next, it's actually going to return an object which has a cancel method on it. And then we'll capture that outside the call. So we run and cancel this generator function. While it's running, we're going to set another timeout that will actually trigger after 3 seconds. And so what's going to happen there is it will start by yielding the 10. It will wait for 2 seconds. It'll yield for 20. It'll start waiting for 2 more seconds. But actually, in the middle of that wait, this timeout is going to happen here. We're going to call cancel, and that's going to kill the generator function and stop it from running. So we never get to this yield 30 point because we've actually canceled the generator from the outside. And this is a really, again, like a really powerful way to like manage your generator function without the generator function having to know about how it's being used when you're writing it. And of course, although we cancel it by calling, where's it gone? Generator return at the bottom here. And because we're telling the generator to return, to stop working, this finally block will actually get executed as well. So that you can make sure that even though the generator function doesn't know if it's going to get cancelled and when, you can ensure that any cleanup that needs to happen is gonna happen at the right point. So all of this is generic JavaScript or TypeScript, whatever. It's standard stuff. It can work in any environment. Node.js, any browser, they all support this nowadays. So I wanted to just talk quickly about a use case which might be more appropriate for Angular developers. When I was looking around, I came across a chap called John Rimmer. He's actually based in the UK. And a few years ago, he wrote a cool blog post, which I've linked to here. So if you're looking at the slides, you can go and click on his blog post and read up on this. And he was having similar problems that I was around managing these async actions in Redux, although in his case, it was NGRX. And so he had this example, which is that he wants to go and get a user, which is an async operation, and then use that ID from the user to actually load some permissions, and then based on those permissions decide whether he wants to load some entities. And then all of this time he wants to have a spinner running while it's doing all of this work, and then if there are any errors he wants to catch those. I'm not an NGRX expert, but if there are any out there, I'm sure you've kind of had similar scenarios, and there's lots of different ways to cope with this, including I remember Victor Savkin has talked about this aggregator pattern, and there are other ways of dealing with this with async await and so on. But if you try and just do it with pure Rxjs, then you end up something like this. Now, again, this is not my forte, so probably someone who's much better at Rxjs can write this perhaps more cleanly, or you can pull out bits into helper functions and so on. But what I see when I look at this is a very complicated expression, which it takes a lot of brain power for me to comprehend what's going on here. I find it really difficult, even if you do know what the switch maps and concats and so on do. You have to really think hard about what exactly is going to happen here. The comparable approach using a generator is something that ends up looking like this. Now here we've got a class method called loadUserGen, which has got a star in front of it, which tells us it's a generator function. But look at this. You can just read the code as though it's a normal function. Like, we're starting by saying there's going to be an action which is going to send a value to the store called show spinner. So that's going to kick off the spinner. And then I'm going to go and get this user, and I'm going to wait for it because it's asynchronous. When that comes back, I'm going to go and use the ID that came out of that to get the permissions. When that comes back, I'm going to then trigger another action on the store, which is that the user's loaded successfully, and this is the data. Then I'm going to do a test to see if that permissions has the right stuff. And if it has, then I'll actually then go and get some post data, and I'm waiting again for that to happen. Then I'm going to send another action to the store saying, hey, I've got the posts. And then finally, at the end, literally finally, we'll then turn off the spinner. And at any point, if any of this has an error in it, then we catch that error and we will send a notify error action to the store. Now, for me, this is just so much easier to read than this. But then again, I don't use Rxjs really deeply. And probably some of you would say that there's a better way of doing this. But for me, I love the kind of the imperative view of this, and how easy anyone could come to this code. And even if they don't understand generators and they don't understand Rxjs or NGRX, they could probably have a good idea of what this is trying to achieve. Now, the way that this works is that in NGRX, you have this idea of creating an effect. And we have to create this special driver function called fromGenerator, this is a custom thing that we built, which will take the loadUserGenerator generator function and drive it through a switch map in order to get the final correct events out through the effect and into the store. I'm not going to show what the from generator looks like, but if you go and click on this link here, the NGRX Saga bit.ly, then you'll link through to a GitHub repository where I've got this up and running, and you can go and play with it. So that kind of brings us full circle, right? So we've gone through like what iterators are, what iterables are, what generators, generator functions, how you can use them, how you might be able to use them for doing state management inside NGRX. This also applies to things like NGXS. I was talking with Mark Whitfield from the NGXS team, and he was, oh yeah, we could totally support something like that in NGXS as well. And you can also then now maybe start to see what a Saga is doing. So in a Saga, it's a little bit different to the NGXS effects, because what you're actually doing is linking it up with the store, and you've got these things called take and call, and sorry, take and put. And take and put are taking something from the store or putting it back into the store. So what take does is when you hit a take, it will actually block and wait for that effect, for that value to be triggered on the store, and it will just, this generator, this Saga will just wait and block until that is ready to go. The call is basically delegating through, similar to when we had like a yield star before. It's delegating through to some other Saga. So what you can see here is that here we're going to delegate through to the login Saga. So we're actually going to go all the way up here and run this login. And then, oh no, sorry, that's the auth Saga. That's delegating to an asynchronous call. What we're actually doing here is this auth Saga is racing these two Sagas against each other to see which one completes first. And then when one of these completes, it will cancel the other one. And these are these two other ones here, the login Saga and the logout. We can talk about exactly what that means. If you've got access to the slides, you can go and click on loads of links of stuff that I think is really interesting from the generator side of things. Now, that's the end of the main talk. I've got some bonus content, but we can either go through this or we can take questions. It's up to you, or we can do both. We can take questions, then do the bonus content, or we can do the bonus content and then take some questions at the end. What does everyone like to do?
I saw one question from Glenn in the
Oh,
chat.
I missed that.
When you're done with it, do you have to destroy it?
Okay. So when you're finished with a generator, do you have to destroy it? Generator is just an object, right? So as long as it's referenced, then it won't get garbage collected. But as soon as it's no longer referenced by anything, the garbage collector will just take it away and remove it. When it gets garbage collected, you don't trigger the return. So it won't go through the finally block at all. It literally just, nothing happens to it anymore. It's paused, and then it just disappears. It gets removed from memory. So if you know that you're no longer going to need the values from a generator, and you'd like to give it a chance to clean itself up, then you would do generator.return to make sure that it does its cleanup. Otherwise, you just stop referencing it, and the garbage collector will just wipe it out.
All right. I would love to see the bonus content. I know, well, what do you think, Sonder? And anybody else who has questions, raise your hand. This would be a great time if you have questions. Sonder, you want discussion or you want the bonus content?
I want the bonus content, but I have a question about your Saga that races login to log out. Okay.
All right. So let's do that question first, because I think we can probably handle that, and then we will. Then I'll go to the bonus content, which is only like a few slides, but it's just a couple of really cool bits of tech, which I think would be interesting for you to know about. So what's your question about racing?
Well, your out Saga, you're racing those two, but so basically if there is a logout call, the other one gets cancelled?
Exactly, yeah. So what will happen, and this is kind of where I very much started from. What I wanted was the user clicks login, and we begin this asynchronous process to actually go and contact Firebase to do the authorization, authentication, and then it comes back. But I wanted a scenario where it's like, okay, I've clicked the login and it's doing its login thing, but then the user wants to cancel that, so they click log out. Now, what I needed was a way to then tell the login to stop doing its thing and to just give up, because I didn't want it to kind of start its logging in, me to click log out, and then it kind of finishes its logging in and tells me that I'm logged in, even though I actually just logged out. So the way that Sagas work is that as soon as in a race, if the logout completes, then the login Saga will have an error thrown into it. And you can see here what happens is it catches the error, and it's a special kind of error, which is a cancel error. So if you know that the error is a cancel error, then you say, okay, it's fine, I can just move on. They were canceling me, I should just stop doing what I'm doing. But if it's not a cancel error, then I know that something bad happened in the login, so I'm going to put a value back into the store saying, hey, it was bad.
Now I understand why the race is there.
Yeah. So it's basically because I wanted to be able to cancel things. And you can do this kind of thing with Rxjs, but again, it gets really convoluted and tricky. And this is one of the things I really like about this. Something that's not in my bonus content is this thing called Csp Channels. And Csp is a thing called content, something sequential processing. I forgot what the C stands. Concurrent sequential processing. And it was a computer sciencey thing created by someone called Hoare in the 1980s, and he wrote this really difficult to read, dry white paper on it.
I read it.
Yeah, of course, yeah. It's great bedtime reading, and in it he has these various actors or processes, and the processes communicate to each other through channels. But what happens is when you're communicating, you can block on waiting for the other end to actually deal with the thing that you've sent through the channel, and you can also wait for something to be sent to you on a channel. And this is how the Go language works. It has this CSP Go routines which can talk to each other through channels. And it's a very clever way of coordinating asynchronous processes. And you can do this with generators too, because you can have generators that can then yield values onto a channel or wait for them to come back off, which is kind of what's happening with Sagas here. So I would really recommend looking at CSP channels. There is a JS CSP library out there, but it hasn't been maintained for like 3 years. Right, let's do the bonus content, and then we can have last questions. So everyone's heard of Rxjs, right? It's the big thing. Everyone in the JavaScript world knows, at least has heard of it, if not used it. There's also a thing called Rxjs, and it's actually created by the Reactivex team. So if you go to the Reactivex repository or on GitHub, there are two projects. One's called Rxjs and one's called Ixjs. And Ixjs is the twin sister of Rxjs. And basically, almost all of the API is exactly the same. So you've got the same kind of operators. You pipe them together. But instead of it being an observable that's triggering this pipe of transformations, you've got an iterable that's triggering that's providing the source for these changes. And instead of having a subscription, you actually iterate through it. Now, the big difference between Rxjs and Ixjs is that in Rxjs, it is push-based. So the observer pushes values through the pipe to the subscriber. And the subscriber gets no control over this. They just have to receive what they get, right? So once they've subscribed, every time something comes, they get sent this thing and they have to handle it. With Ixjs, it's the other way around. It's a pull process. So you set up this generator or this iterable, and you then create the pipeline. But then when you want a value, you actually ask for one. So it's the subscribing side that pulls values from the generator when they want them. So it's a different way of thinking about things. But what's really cool is that many of the operators have the same idea, and you can set them up in the same way. So if you want to go to the Rxjs repository or website and look, you'll see all these operators, and they have very similar names, and the API is really similar. But no one ever knows about it because no one uses generators, right? So it's a very sad project in my view. And then the other thing I wanted to talk about was this really cool library, which you have to go and look at, called Affection. And I've just totally forgotten the company that builds this. I think they're called Frontside. I do apologize if I've got that wrong. They've got a great Discord channel, and they do a lot of their work on these kind of open source projects in Discord. So you can literally go and hang out with the people who are building this stuff. Now, Affection is a library that provides this thing called structured concurrency. And there's a really cool blog post that I put in the links that I just went through earlier on about what structured concurrency is. But the basic idea is that when you spawn off a child process from a parent process, those child processes should live no longer than the life of the parent. So the parent always outlives the child's lifetime. So here what we've got is a main. This main is the driving function, similar to the flow or the other drivers that we had earlier. And we pass in a generator, and then we can yield off new child processes. So we're actually yielding off a call to get fetch weekday twice. So these two things run in parallel. And then only when we yield the value from that gets returned from this spawned thing, that is when this will block and wait for that to come back. And so we block on that one, then we block on that one, and then we can exit. Now, if either of these never returned, then this whole main function would just wait, because it's waiting until these things finish. Even if you didn't yield to these values, the main function would wait until these two things had completed before it exited itself. This is what Affection does. It makes sure that when you start a child process, you never leave it orphaned, hanging around on its own without it stopping. So let's have a look at what that could look like in sort of more visual terms. So here you can see we started the main function, and it's kicked off both of these two child processes. Now, while they're both still running, the main one is suspended. It's not going to move forward. Then what will happen is one of them will complete, but the other one hasn't completed. So we're still suspended. And then finally, when the last one completes, then we can finish and complete the whole of the process. Now, this is not that amazing, but what's pretty cool is when you start thinking about if there's an error. So imagine both of these are kicked off again. So the main process is suspended, and these two processes are running. Now, if this one here crashes for some reason and errors, what do you want to happen? Like, do you want this one to continue running? Do you want this one to continue running? Like what would be the best way to do this? Now, the idea of structured concurrency is that if one of these fails, then the parent has to fail as well. And if the parent fails, then the other running ones have to be halted and told to stop doing what they're doing. So this is basically what happens.
Meeting, sorry.
No worries, Sander. Good to speak to you. So this is actually handled for you by Affection. So it knows that if one of these things fails, the whole thing fails, but it also tells the other child process to stop. Because otherwise what would happen is this child process would just carry on running past the lifetime of the parent. So that is like the really 101, very short introduction to Affection. But I thoroughly recommend going and looking at this Affection library, because it's got lots of really nice features. And if you're doing any kind of concurrent processing in your tool, in your apps, there's a lot of power to be had here that would solve lots of problems and remove lots of boilerplate from your code. Those are my two bonuses. So I'm happy to take some questions for, I don't know, let's say 10 minutes.
We may have fried our brains. I've never seen this. I've never seen the, I didn't even know that we could do this. And it's been there the whole time. It's crazy. I love this. I love that, because like you can do it with Rxjs, but I really agree with you that it's easier to read, and it's just easier to understand. I mean, Rxjs does it, but I think it's better readability. Tom has a question.
Yeah, go Tom.
Yep. Hi. It may be a silly question, and it may have missed something, but is it a one-to-one relationship? So if I have a generator function and I call it, can another somewhere else call that generator function, and then kind of, you'd have a 2-to-1 relationship, and there'd be different state, or?
Absolutely. So every time you call a generator function, it will create a new instance of a generator. And so, and all of those generators are completely independent of each other. They won't know about each other at all. They have their own internal state.
Okay. Yeah.
Just like if you had a normal function that returned an object, right? Every that object is going to be created new each time you call that function.
Mm-hmm. Okay, so it's not like you can collaborate or have multiple. Well, I guess what I want to call subscribers. I know they're not subscribers, but yeah.
Well, what you can do is you call the generator function, it returns you a generator, and then you can share that generator between different users of that generator, if that makes sense. But what you have to realize is that if one of them calls next, they will get that value, and the other one won't get that value because they didn't call next. But there are things inside Rxjs that allow you to then share values between different, like from a single generator. There's I've forgotten what the Rxjs operator is, but it basically allows multiple consumers to consume a single pipeline, which is probably the sort of thing that you're thinking about.
Yeah. Okay, great, thanks.
Question from Sander. So Sander said, does it affect when you spawn a new process with affection? Is it actually a new thread? Or it's not. So JavaScript is single threaded, right? This is not actual threaded programming. The threading is it's what's the word? Like multicasted. So it's the main that's actually allowing things to run. And so every time you hit a yield, then it's allowing the next thing that's ready to carry on running, do its thing. But obviously, if these fetch weekday things here could be promises, could be returning promises, so they would. So these fetch weekdays could be a kind of promise-based thing, which means that when they finish, their value will then be yielded out. So these two things would block until like the first promise finishes and so on. So that can run in the background, and then the promise will then eventually resolve. What's really cool though is that you can actually make these fetch weekdays into what we call cancelable promises. So it looks like a promise, but actually what will happen is if say one of these crashes, we can actually send a message all the way through to this spawned child process, and it will then tell the fetch weekday, hey, stop what you're doing. So if it was actually calling the fetch API has a cancel behavior on it. So with a normal async await, you wouldn't be able to cancel that because the fetch would have to carry on. But with this, when one spawned process dies, the other one could actually tell the other one to stop, and then the actual fetch operation could be told to stop as well. So it can flood all the way back. That being said, there's nothing stopping you from potentially triggering things to run, say, in web workers or separate threads, as long as you have a way of communicating across. And this is where Csp channels can come in, because a Csp channel can actually cross boundaries to another place, as long as you built that in a way that works that way. So you obviously have to, the value being passed across has to be the appropriate kind of value that can't be shared memory, for instance. Although there's this thing called atomics, which is cool and new, which potentially would allow that to happen as well.
This is cool. Maybe we should reach out to the front side team and see if they can come by and go into a little more details. I have not seen that. I learned so much today, Pete.
Cool. This has like been a little pet thing of mine for so many years, and I kept saying to myself, I need to give a talk about this, but I could never really feel that I had enough good use cases and good reasons to tell people about it. But I thought maybe now's just the time. I'm just going to bite the bullet and actually talk about it a bit, and that will maybe inspire some people to go and read up on it themselves and maybe build some cool things. There's definitely some arguments against all of this stuff. And I've kind of proposed all this as like wonderful and exciting and cool and new, but there's obviously a reason why it hasn't taken on, and I can't quite put my finger on it. I don't know if it's just because people don't really understand it, and it's a kind of a move away from what they normally understand, or whether there are some fundamental problems in terms of scaling it and maintaining it and so on.
It is just as hard to learn as Rxjs is.
Yeah,
That's
I think because it's cleaner and it's easier to read. But if I already know how to do it the old way, then I would just probably keep doing it the old way because I don't have time to learn something new. And I think maybe getting across that learning curve, like now that we've seen it, we can see all the ways where, yeah, that would come in handy here and there, but like we have to know about it and have exposure to it.
Yeah, I like generators. I'm using them occasionally, but I have found that I often find Rxjs more usable because it's push based, and this is pull based, and I don't know.
So one of the things is that most UI based applications, which includes browsers, right, are reactive. Right.
Yeah.
By definition, they're reactive. The user is triggering something, and we need to react to that input that's changed or that button click or whatever.
Yeah.
So in that case, this kind of Rxjs way of thinking isn't quite the right approach, because you have to ask for the value, and then you're waiting for the person to click the button, and then you get that value out or whatever. So it kind of goes against the way that your brain understands. But if you look in my list of cool things to read up on, yeah, there's actually this thing called Crank.js, which is amazing. It is React based, but you could apply it to almost anything. But basically, it's not actually React based. It looks like React because it uses JSX, but basically the whole thing is just one massive generator. So like your entire app is just like generators inside generators, and it's a really clever, cool little project. But I think the place where generators is really going to have an impact is in these small use cases. So although state management is a really cool thing to think about, where people probably like Xander is using this a lot more is like in small places where you've got some lazy loaded thing which you don't want to have to iterate over the entire thing because you're not sure you're going to need everything. And so having a generator dealing with that allows you to have these kind of infinite sequences and lazy loaded sequences without having to do the entire thing in memory. Like if you imagine, I want to filter only every other value from a stream. If you do that with a filter, you've literally got to filter the entire array. And if the array is like 5 gigabytes in size, because you're loading it in through from streaming it in from a disk, then you're going to have to pull the whole thing into memory in order to do that filter. Whereas with a generator, you can pull in each value and decide whether it gets included in the thing that's being passed out. It's very similar to how Rxjs works, but more of a pull side of things.
So cool.
Anyway, I could talk about this thing all day long.
Also, a good use case is state machines. If you want to do anything with a state machine, if you need a state machine for some piece in your application, they come in really handy in those cases.
Yeah, absolutely.
Then again, I haven't found a use case for a state machine in practical use for years, but I know it's there.
Well, of course, NGRX is basically just a big state machine, or NGRX store. And so arguably, most applications are just big state machines, but I totally get where you're coming from. And that's why, I looked in the Angular source code and there's almost I think I found 5 places where we use generators, and 3 of those are in tests. So I have a look around. Now that you know about them, you'll see them popping up occasionally. And I think you'll find it interesting. It's like when you first start learning to drive, you suddenly notice there are all these people with L plates on their cars, right? That you never noticed before.
This was very cool. Okay, we have gone past our time. Thank you so much. And we have a little tradition here on Angular Nation. You guys know the drill. If you can all please come off mute and help me thank our guest.
Thanks, Pete. That's great.
Thank you, Pete.
Thank you, Pete.
Thank you, Pete.
Thank you, Pete.
Thank you, Pete. Thanks.
Amazing talk.
Thank you, Pete.
Carmen, hey, I didn't see you there.
Hey.
Well, thank
All
you
right.
to everyone. Thank you for having me. I really enjoyed being here, and hopefully it was some interest to you all.
Absolutely. Come back soon. I'm going to turn off the recording. We'll stay in chat for just a minute. Really great talk. Thank you so much.